I breaks it down to the bone gristle. Ill speaking, scud missile, heat seeking. Johnny blazing, nightmares like West Craven.
Okay, so it's important to note that parallel planes, so parallel planes, that means that they don't intersect at all or anywhere. They have the same normal vector, or they should have the same normal vector, and that's denoted by an N arrow, right? It could be the same normal vector, like the exact same, or it could be scalar multiples of that normal vector. Scalar multiples of that same vector. Okay, and here's what I mean by that a condition for parallel planes is to have the same normal vector, or at least the same scalar multiples of that vector. So, like, let's say we have a plane here, okay, and here's our normal vector pointing straight up, okay, and for another plane to be parallel with that, like to not touch at all, it doesn't necessarily have to be the exact same, like pointing up like that, but it does, it could be longer, let's say. It could be longer, which definitely is not the same vector. It's not the same N arrow, but it is pointing in the same direction. It could be a scalar multiple, right? If it's pointing in the same direction, it could just be a different length, okay? Or we could even have a plane that is parallel, but it has the normal vector pointing in the complete opposite direction. That would be a scalar multiple when our lambda is negative. Remember, that would flip it around, but it goes along the same line, right? So this could also be a normal vector that is a scalar multiple of this original one here, and this one as well. And that gives you parallel planes. Okay, so another thing to note is to find a normal vector if you're asked to do so. So to find a normal vector, I'll just put a normal vector there. What you have to do first is find two vectors that lie in the plane, so in the plane you're concerned with, so in the plane in question, and so that's the first thing you have to do. You got to find two vectors in the plane, then you take the cross product. Okay, so here we see an application of the cross product, and remember, this is because we do so because we want to find, let's say, okay, so here we have a plane, all right? So what we have to do is find a vector in it, and we have to find another vector in it, okay? And then when you cross those two, let's say it's V and W, okay? So when you cross those two, the resultant vector that you obtain from taking the cross product, that's going to be orthogonal to both of your original vectors, okay? So we're going to get something that looks like that, okay? So this N is going to be perpendicular to V. It's going to also be perpendicular to W. So we found a unique, well, not a unique, but a solution, or a solution for our normal vector to the plane. Okay, so let's actually do an example of that. That might be easier to explain if we do a calculation. So what we're going to do is find a normal vector, find N arrow to the plane containing the following. So containing, and I'll give you a few points here. So we have P, a point P, that's 1, 0, negative 1. Okay, and we have a point Q, which is 2, 2, 1. And we finally have a point R, which is 4, 1, 2. That's a 2, sorry. 2 there. Okay, so let's see what we have. So we have some point P. Okay, I'm not going to draw like a graph and everything because I think the most important part here is just that you get the visual. So let's say point Q is here, and point R is over here. Okay, so we have these points, and like I said, this is probably not graphically correct at all, but anyways, the concept is that we have to find these 3 points define a unique plane, okay? 2 points, if you have only 2 points, that defines a line, but you have the plane rotating about them. Anyways, if you have 3 points, 3 fixed points, that is your plane. I'll move the P there. Okay, so what we're going to do, my plan is to find, remember, to find the normal vector, we have to define, or just find, 2 vectors in the plane. So find 2 vectors in the plane, Okay, and the way we're going to do so is we could just basically just connect, go from one point to another, draw a little arrow. So this is vector PQ, all right? So we can find a vector PQ. We're going to calculate that, and we can find a vector PR we could do. So I'm just going to pretend that connected to the R there. All right, there we go. So then we're also going to find a PR, all right? So this is the first step. So let's do this. So PQ, to find that, we're going to take the, we're going to subtract the components of the end point, so Q, minus the components of the P point. So that'd be 2 minus 1 for the first one, 2 minus 0, and 1 minus a negative 1, okay? So that's going to turn out to be a 1, a 2, and another 2, okay? So we have 1, 2, 2. Those are the directions for our new vector, PQ. All right, so we found one, and now let's find the other one. So PR, we're going to do the same thing, but this time our endpoint is R, so we're going to do those components minus the components of P. So that would be 4 minus 1, a 1 minus 0, and 2 minus a negative 1, okay? So what we're going to get for PR is 3, 1, and a 3, okay? So we found two vectors. We're halfway through, and now all we have to do is the second step to find the normal vector, so that is to take the cross product of those two, all right? And by taking the cross product, again, what we're going to do is obtain some vector that is orthogonal, is perpendicular, to both PQ and PR, okay? So this is our normal vector we're going to get. Okay, so I'll continue this on the next slide. Alright, so what we're going to do is find the normal vector by taking the cross product of PQ with PR, the ones that we just found. So that would be crossing, let's see, we have 1, 2, 2 crossed with 3, 1, 3. Okay? Alright, so let's set this up. Now we know how to take the cross product. So we're going to set this up, and we're going to write our I hat, J hat, and K hat at the top. And then we write our PQ ones first, so 1, 2, 2. And then we write our PR ones, 3, 1, 3. Okay, so let's continue computing this. So we have our I hat. We're going to circle that, cross out everything that's in line horizontally and vertically, and write the minor that's left over, 2, 2, 1, 3. That's left in the bottom right. We're going to write the minus sign in, the all-important minus sign. Our J hat is the next one, so we're going to cross out everything in line with that. And we're left with 1, 3, and 2, 3. And finally, we have our K hat. We're going to cross out everything in line with that, and we're left with 1, 2, 1, 2, 3, 1. Okay? Alright, so now let's continue, and we have our normal vector here, and we're going to get I hat times 2 times 3, 6, minus 2 times 1 is a 2. Then we have our minus J hat, and we have 1 times 3, so 3, not a 1. 3 minus 2 times 3, which is a 6, okay? And then we have our K hat, which is going to be 1 times 1 minus 2 times 3, which is a 6. Okay, so let's continue writing this here. So we have a 4, positive 4i, and then we have a minus 3, so plus 3 J hat, and lastly a negative 5 K hat, okay? And to write this as a vector is 4, 3, negative 5. All right? So this is ultimately our normal vector to the plane. Okay?
Put the bunion on my big toe, I keeps it moving. Know just what the fuck I'm doing. Rap insomniac, fiend to catch a nigga snoozing. Slip the cardiac, arrest me. Exorcist.